Hello and welcome back to another episode. This one is homework. Finally, we made it 1.5, including the retrieval, which is now just going to be uploaded with the homework. Give the name of the geometric figure that fits the following characteristics. Blank. Oh, next page. A polygon with 5 sides. That is what we call a pentagon. And the home plate of a baseball diamond is a pentagon. So is a house. When you're drawing a little house, you put a little chimney on there. Now we're having fun. A door, maybe. But that's not a regular pentagon. A regular pentagon has to lean out a little bit. Remember, regular shapes have all same size sides and all same size angles. So this is also not a regular pentagon because my sides are all different, but my angles are pretty close. So I'm halfway there. A polygon with 6 sides is a hexagon. Most famous shape in the world. Polygon with 8 congruent sides is an octagon. It's like a hexagon, but on the side there's an extra little straight piece. Or if you want to look at it this way, it's a square with the corners cut off. So this shape is an octagon. Given, I didn't write it, octagon. Given the following table, write the equations of the lines described. Okay, the way you do this is you take this number, you subtract that number. So 2 minus 5, negative 3. You take this number, subtract that number. Negative 1 minus 2, negative 3. Take this number, subtract that number. Now it's getting a little tricky. I have to make note. Negative 4 minus negative 1, subtracting negativity, that's like adding, negative 3. And I think you get the point. So this is the slope, because as x goes forward 1, y is rising down 3. So if I wanted to write a slope-intercept version, now all I need to know is where is the y-intercept? Well, here it is. It's where the x-coordinate is 0. 0, comma, negative 1. So I need that little piece of data in the equation. So if I put 0 in, negative 3 times 0 is 0. Minus 1 is negative 1. So we put 0 in, we got out negative 1. We need that to be true. That's the y-intercept. Perfect. The line that contains all of the points in the table. We did that already. We did that. The line that is parallel to the line given by the table, but has a y-intercept at the point 0, 6. No problem. It's parallel, so same slope. Different y-intercept. Positive 6, though, right? Yeah. See, I can read. The line that is perpendicular to the line given by the table has a y-intercept at the point 0, 6. Flip it. Oop. Switch it. So it's going up by 1/3 instead of down by 3. I'm just going to leave it there. Plus 1/3. Positive 1/3. And then the homework begins. Define a polygon. To Google this. Google all these. I'll give you 7 though. We should go with heptagon. You will also see septagon. But septagon is a problem like September, which is the 7th month of the year. Right now is the 7th month of the year. If you start counting in March, which used to be the first month, before the Romans changed the calendar. So they use sept, but agon, that's Greek. So it's kind of weird we're mixing Latin and Greek, which is fine. People do that. Septagon, big deal. But if you want to stay Greek in Greek, it would be heptagon. All the other ones are less controversial. One quadrilateral with special attributes as a kite. Find the geometric definition of a kite and write it below along with a sketch. Okay, find it. I guess you have to use the internet. No problem for you guys. Draw a kite and include all the lines of reflective symmetry and all of the diagonals. Remember, I won't draw a kite, but I'll draw a rectangle. The diagonals are not lines of symmetry, but there they are. They wanted those. And then these are lines of symmetry. Now the kite will be different, but that's what you're drawing. I guess separately. I should have done those in two different drawings. Diagonals, lines of symmetry. List any rotational symmetry for a kite. Be careful with that one. Consider quadrilaterals such as parallelogram, rectangle, square, rhombus, and kite for the following questions. Are lines of symmetry also diagonals for any given polygon? Explain. Well, we seem to already have countervailing evidence. Are all diagonals also lines of symmetry for any given polygon? That's a slightly different question. One's asking about the lines of symmetry are also diagonals. One's asking about the diagonals. Also, are they lines of symmetry? Maybe. Which quadrilaterals have diagonals that are not lines of symmetry? Draw 'em. Do parallelograms have diagonals that are lines of symmetry? That was, you can go back to the lesson. We had a parallelogram, and we tried to draw lines of symmetry. And finally, the go. We want parallel and perpendicular lines. So parallel, okay, this is great. This is giving you the y-intercept number, which is represented after the slope times x. Why is my camera blurry? Pause for technical difficulty. I found the autofocus button. Hopefully you've been able to follow along until now. If not, send me an email. Also, if you find any mistakes, we're going to start writing my mistakes up on the board, just so everybody's aware of them. Table of a line. Where is it? Next page. So, using our technique again, negative 10 minus negative 8. Subtracting negativity is actually like getting positiver. You know how to do it. Find the slope, the rate of change. By the way, always just glance at your x column, make sure 4 minus 3 is 1, 5 minus 4 is 1. They're going up by ones. You don't want to take this number as a slope unless this number is a 1. And every once in a while, these won't be all different by 1, and you'll have to include that information in the slope. It's easy to do. You just put it like that. You just put this number is the x change. Remember, slope is change in y over change in x. Delta y over delta x. Delta is a Greek letter. It's also a triangle. And the physicists and chemists use it to mean change. Delta is the universal symbol for change amongst mathematicians and scientists. Okay, you're going to have to find your own slope. Yeah, you guys got this. All right. Have fun, and I'll see you in the next one.